Student t-test for independent or unrelated or unpaired samples in SPSS. Student t-test is a parametric test that can be performed when there are only two groups and the data in these two groups are normally distributed and have unequal variances. So there are two assumptions that have to be fulfilled before performing student t-test for independent samples or unpaired samples. The first assumption is that the data should be normally distributed. The second assumption is that both groups or samples have equal variances. Student t-test is a robust test that can be used when even the equal variances assumption is violated. Here in this SPSS data view, I have two variables. The first one is the gender, which is the independent variable, which is the grouping variable. So there are two groups, male and females. There are 100 participants here and there are 50 participants in each group. And if we click on the variable view and then click on values, the value 0 is given to male and value 1 is assigned to females. And if we go back again to the data view, and as shown here, 0 for male and 1 for females. The second variable, which is the dependent variable, is a scale variable, as shown here by the variable view, is a scale, and it is measured in centimeter, which is the height of each individual. To find out whether there is a difference in the height between male and females and whether the males are taller or shorter than females, then student t-test will be performed. And since the data here or the samples are unrelated, as we have here two separate groups, male and females, and they are not related, then the independent student t-test will be performed, independent sample test. And to do that test, click on analyze, scroll down to compare means, and then click on the independent sample t-test. A new window will appear here. Move the height, which is the dependent variable, into the test variable, and the gender into the grouping variable, and then click on define groups. And the groups are given a value for 0 for male and 1 for females. Click on continue and then tick on options. No changes will be performed here. Click on continue and then we'll keep this estimate effect size ticked. If we click on OK, 3 tables are generated in the output of the SPSS. The first table is a descriptive, showing that the gender have two groups, males and females, and there are 50 participants in each group. So two groups, male and females, and the mean or the average for the height of the male or males are 169.35, and for females it is 160.40. From these values there is a difference between the height of the male group compared to the female groups. Whether this is significant or not, we will prove that in the subsequent table. And also in the descriptive statistics, a standard deviation is given here. As for the male, it is 10.5, and for female, it is 9.27. So this standard deviation indicates that there might be an equal of variances, as the variance is the square of the standard deviation. And then the standard error of the mean is given here. In the second table, which is the major table here, there are different sections. The first section is the Levin's test for equality of variances. So this test will test whether there is equal variances or not equal variances between the two groups, the male and the females. And the SPSS will generate an output, a table, a t-test for both when there is equal variances assumed and when there is unequal variances. As for the Levin's test here, the significant value is greater than 0.05. So we need this value to be greater than 0.05. Once it is greater than 0.05, which is in this case 0.387, this indicates that the two groups, male and females, have an equal variances. So the assumptions for performing the independent sample t-test is fulfilled here. So there is no need to look at the values for unequal variances. In the table also, the t-test value is calculated and given here as 4.5 and a degree of freedom, and then significant value when there is one-sided p value and two-sided p value. And the p value here as shown will be look at, and the p value to look at is the two-sided one, as here our null hypothesis states that there is no differences between the height for the two groups, and the alternative hypothesis says that there is a difference between the height for these two groups. And since the value here for the p-value is less than 0.05, this indicates that there is a significant difference between the height for males compared to females, and the males have a higher height or are taller than females, as statistically proven by the independent sample t-test. In addition to the p-value, also mean differences is calculated, which is the difference between the mean for the males and the females, which is 8.9, and a standard error for the difference is given also here. What is important to consider in this table is the 95% confidence interval of the difference for the mean. So this is a second layer of assuring that there is a significant differences between the two groups in terms of the height or tallness. And as the mean difference is equal to 8.9 between the two groups, the 95% confident interval is between an upper and a lower value, and this mean difference fall between these two values. And since the values for the lower and the upper doesn't cross the zero value, then this also give another assurance that there is a significant difference between males and females, and males are taller than females. This is confirmed by performing the student t-test for unpaired samples. If in case that there were unequal variances, then the value to consider and to look at and to interpret will be the second row here for unequal variances, which has a t-test, a degree of freedom, and the p-value. So this is the way to perform student t-test for unpaired samples in SPSS when there are two groups of data and the data in both groups are normally distributed and have unequal variances.